Namaste. Here I'm going to show you how to use the clock in the FPGA, and this is the FPGA which is provided by the Agimus Technologies, and this is the Xilinx Spartan 6 FPGA. Okay, this is the Xilinx Spartan 6 FPGA board which is provided by the Agimus Technologies, and yeah, basically it's an internship, and myself Rohit DH from Canada Engineering College. And this is the simple verilog program for using the clock in the board, that means in the FPGA onboard clock. So here just like it's a module counter, and input is the clock, and a reset, we need reset for that clock. Then output, here we are using the register in order to store the 4-bit. Here the clock is from 000. That means we are just designing simple counter using this clock, so which counts from 0000 to 1111. Okay, 4-bit. So for that, here we are going to use always block. So we must have to it has to be reg. Okay, register we need to use for the always block. Then the clock frequency is too high, like this is a 12 megahertz clock, so we need to just reduce that. That is called as the clock division. So here by using the clock's division of 22, that means 22 bit. Okay, so here you can see 22, 0 to 22 clock division, that means I think it is basically going to be 23. Okay, then always set percentage of clock, that means the positive edge, it will going to just increment this clock division by 1, and when this clock division becomes okay, yeah, here we can see division equals to clock division of 22. That means this 22 bit, here we are having 0 to 22, that last bit we are assigning to the division. When this division, that means when that last bit will going to change it from the positive to the negative, like the waveform, okay, like 1010, like that last bit, that means it will be taking some time for that. So we can reduce the actual clock speed to the whatever we want in the applications. So here always set positive edge of that division, that means division is the last bit. We are just incrementing the count by 1. Okay, so and here you can see we define the counter to be the register which is 012. We are doing like a 4-bit. So in UCF file, yeah, there are one is the clock, this for the clock, it's the onboard clock, and this is the reset, and these 4 are for the, that means LED. Okay, now for visualization I use this LED pins. Then we just need to upload this code to the FPGA. I think you've understand about these things. Yeah, it is already generated, and I just need to upload this. So just right click, and yeah, and yeah, here we can see this. Okay, yeah, now I'm just going to upload that, this counter. Okay, just a simple counter. Yeah, here I think you can see now. Oh, sorry, I just did that. Where is that? Yeah, I think now it's visible properly. Then I just need to click here, okay, and this I have to upload now. I'm just clicking this and program. Now you can see 1 2 3 4 5 6 7. This is the MSB. Okay, this is the MSB. Yeah, it is counting till 15. 0 and 1 2. I think you come to now what is this clock is going to do. So if we make this clock division to very less, then it will just going to, yeah, here instead of 22 I'm just giving this as a 2. Okay, here also 2. Then if we just generate this program file, and if you upload that time, you will see now actually we can see the differences like this. in the physical sense you can see the difference of changing these things. This clock is required in many applications like the LCD and in other applications. In the next video I just showed how to use the LCD also. So here, yeah, this simple clock applications that will require in the next video, so that this becomes the prerequisite for that. Yeah, it's generated. I just need to upload, so instead of simply opening the another, you can upload here itself. Counter.pet. Yeah, now I just have to program this. Now you can okay, yes. Now if we see here, it is actually changing at a very fast rate, so we cannot able to differentiate that. It's like the actual clock frequency is 12 megahertz, so this is I think by 3 I think, or by 2. Just that small calculation here. Okay, division we made that as a 3, so 0 1 2 3 I think it's by 4. So, or not here, yeah, here. So it is 0 1 2 I think it's by 3, so this will become so faster, so we cannot able to differentiate that. That's why here actually we cannot see. Actually it is in a clock it is also counting, but we cannot able to see that difference. I think you've understand about how to use the clock application of this clock. We will see in the next LCD video. Thank you.